Hello all. I think we are live. Welcome to another stream. Welcome to another, I guess, a Saturday evening stream where we're gonna just do some C++ and chill. I've actually got something new here. I've got a VM running Ubuntu where we're gonna just... Okay, I'm hearing myself now. I've actually got something new here. There you go. That's better. At least I know that I can be understood here. So... but yeah, let me know if... hey Robin. Oh shit, you're already here, man. Welcome. Usually like no one joins at the start, so you're the very first person here. But yeah, good seeing you, man. Hope you're doing well. Yeah, so what was I saying? Yeah, I got a VM because I've realized that in the last few streams I sometimes share emails and shit that I, perhaps shouldn't be sharing, and I'm scared I'm gonna like overshare like maybe files or something like that. So for the sake of privacy, we're gonna run from a Ubuntu VM today. Doing good, great. Peter, sir, how is it going, man? Good to see you. Good to see you. Sorry I couldn't stream earlier, guys. I usually stream like every other day on weekdays, but work has been crazy this week. I was working from 8 AM to 1 AM for like the last 2 days of the week, unfortunately. But it is what it is. We're here now. So yeah, I have a VM. We've got Vim configured here. I was actually just finishing my configuration, but I didn't quite get to finish everything entirely because I'm missing some of the plugins that I like to use, such as the File Explorer. You can kind of see what it kind of looks like, and some of the icons here I can figure out that they haven't really worked, but yeah, we'll figure that out. So I thought maybe we can do this on stream, right? Why not? Now let me just increase the font here so you guys can maybe see better. Maybe this conky thing is a little bit too much as well. Maybe we'll kill it. We'll kill it for now. We don't care about that, right? Let's keep the environment clean. So going back to this one. Good. Yeah. Where was I? Yeah, so we've got a C++ project here that we're basically going to be adding some modules to, and this is a project that I pretty much used to develop, used to maintain, and I haven't done anything on it in like 7 months. Hello, Sop. Hello. So we're going to be just adding modules to it because it's been sort of like exported as C++ export headers and all that good stuff that we have to do when we don't have modules enabled. So I thought that would be a good exercise for me to actually get some some practice with C++ modules and refresh my memory on it. Because quite frankly, I think I did a video on it, I think it was like 2 or 3 months ago, or even 4 months ago, and I haven't really touched modules ever since, because quite frankly, not many people use it, not many projects use C++ modules yet. It's just too new. The toolchain for it is just too new. So yeah. It's funny that C++ added modules to make only one CPP file instead of... Yeah, indeed. So that's the main that's the main advantage here. So yeah, first things first, I need to install some sort of like plugins for File Explorer on my new Vim installation here. Because currently, I think I've got fuzzy search, so I can still add Control F. There you go. I can search for the project here for the shit, and I can also search for code itself on Vim. So that is good. But I am missing that kind of like Visual Studio Code File Explorer on the side, and it would be nice to add it, right? So I thought, why not? I'm gonna actually stick to web browsing on my Windows machine because the VM browsers are just too damn slow. I don't know why. I've enabled 3D acceleration on VirtualBox and all the virtualization stuff, and it's still very slow. So we're gonna stick to this. So I think I need a nvim. I think it's called file tree, and the one I was looking at before is called nvim tree. I think this is the one. So we're gonna try and install this one here. It's not too difficult. So let's see if we can install it via Vundle. I'm not too sure now. Nvim tree Vundle. Gotta say, love Kona now. That is, yeah, it's really good when it works. As I said, Robin. The problem is when it doesn't work, then you have to like debug the Python files and figure out what didn't work. But hopefully, you know, you've not had to do that yet. So fingers crossed you don't ever have to do that. It's only really a problem when you're doing like building very large libraries like Qt, OpenCV are some of the libraries that I've had issues with coding before, but yeah. So let's install this, I guess, right? Yeah. Going back here. Okay, let's see if we can open the init vim. Nvim init. Does it hide the config? Yeah, it hides the files. Okay, cool. Apparently the fuzzy finder can't find the hidden files. Config and vim init. So I'm gonna add a call to an installation for the file tree. Oh. Okay, let's control save all this and then install the plugins on Vim with Vundo. Okay, so nvim tree Lua has installed. Cool, and I'm pretty sure this extension needs to be called somewhere as well. Config and vim tree. Okay. So what does this look like in our directory here? Okay, so by the way, I'm just checking out the Stack Overflow to see how to install this extension. So after Lua require and Vim, everything works now. So does this work? If I just go into Vim, and if I do this, I don't know how to open the nvim tree now, you know. Let's find it again. If you guys are interested in this kind of setup here that I've got, there's a video out somewhere where I turn my Raspberry Pi into a C++ IDE, and all the configs that I'm using are there, like NeoVim and Conky and everything else that you can see here. Nvim tree open. So nvim tree open. Okay. Nvim tree open. Yay! It kind of works. This is worrying. I can't see icons here, which is a little bit shit. So I think it's just a matter of Vim not doing UTF-8, so we can figure that out. Next line after plugin. Ah, okay, cool. I'll do that. Did I miss that? And then config. Thank you, Sop. Config and Vim. Maybe I did miss that though, because I don't want to have to call it manually every time. So we've got the APs, and then we've got in Vim. Maybe call it after the Vundo, right? I guess. So we do a require. What is it? Nvim tree setup. This is not exactly what I had before here though. This guy said something else, yeah. Okay, cool. Yeah, that's exactly what he said, my bad. Okay, so in theory, is that everything? No, not an editor command. What am I missing? Oh shit. Yeah, that's the one. Okay, so I guess I just gotta do this. You have Vim, yeah, I have a .vim config, not a NeoVim config, unfortunately. So the syntax is a little bit different, isn't it? Maybe I should change this config into an actual Lua config for this shit. Truth is, I basically just took my Vim config that I had from years ago and ported it to NeoVim. And things might not work exactly. Okay, yeah, so we do this. There you go. That's better. Okay, yeah. Now the only thing that I'm missing are the icons, right? So I guess this is usually because I don't have something like set UTF-A, right? Now I forgot how to do that in Vim, so let's Google it as always. Set UTF-A in Vim. Set encoding UTF-A. Okay, cool. Yeah, we just need this one, just the terminal output. Now, will this work? No, it still doesn't show the icons here. Or is it because I don't have the font for it? Yeah, this might be an issue with the font. Let's see if we can get an actual... Yeah, encoding is UTF-8 here, but then it'll be on my preferences, my font somewhere, wherever the hell that is. Nerd terminal, yeah, I need a nerd terminal font, Cascadia Nerd or something like that. So let me download that. Sup, you know everything, don't you, mate? You're doing well, doing better than me. Font, yeah, this one. Use system. Is it installed here? Nerd? No. Yeah, I need to install a nerd font on my machine. Let's open Firefox. And this is what I mean. When I open the browser inside my VM, it's absolutely like a slug. You'll see it. Of course, I have tabs in here already. But look. Typed in google.com 10 seconds ago. Let's see how long it takes to render this shit. A long time. It's still doing it. I could make a coffee in this time. I did a custom new Vim config. Cool, man. Yeah. I mean, you can definitely help me. Right. I just installed Atom and never used the new Vim again, yeah. But is Atom still a thing? Dude, I've not heard that name in years. Years. Why is it not going to google.com? There you go. I want a nerd font. Download. Yeah, you guys are gonna have to like be stuck here with the slowness with me, unfortunately. This is what we get on the virtual machine, guys. And I apologize for that. Actually, I'm using a community fork called Pulsar. Dude, you are special, man. Not, you know, you're a special person. You're like probably the only person that I know who still uses like some sort of version of Atom. Everyone seems to have moved on to VS Code now, but even that's a bit bloated, in my opinion, sometimes. Same good old Atom was my first editor, yeah. I remember using it at university, you know. That was like nearly 8 years ago. It was, well, first of all, there was no Atom. I used to use something called Sublime Text, if you guys know that. And then I went on to Atom. And then I went on to Visual Studio, and then VS Code. So that was the... Alright, which font do we need here? Cascadia Mono, not Cascadia Cove. Let's go Cascadia Code. So I'm forced to use Community Fork with Working Package Manager. At least it has a Working Package Manager. Where does it download to? My home downloads, okay. Yeah, cool. I can get that. So let's go to downloads and let's unzip this. Unzip Cascadia Code. Dude, that's a lot of fucking fonts, you know. I have to install every single one of them. Open with fonts. Install. Can I not just install all of them at once? Install node font profile. So which one is the one that kind of looks better? install a few different ones and we'll see. Okay, cool. Now we should hopefully have that available to us on the terminal, which is in my case, if you're wondering, this is Terminator, by the way. That's my terminal emulator at this particular stage, this particular point in time. I might change it. This is usually the one I work with, but it's a little bit buggy on the VM for some reason. Anyway, profiles, and then Cascadia. There you go. So what do we want? And let's go for this one. Select. Okay, close. Let's restart all of these terminals now. Those terminals. I'm a VS Code hater. Yeah, dude. I mean, recently, like, it's been crashing for me a few times on my work laptop. So I'm trying to move away from it slowly. Okay, so we have Cascadia Cove. This is not quite visible for you guys, I guess. Let's go for a bold one then. Semi-bold, yeah, select that one. Close. Okay, this is much better, isn't it? I guess. Good. And now, if we split vertically, let's keep a terminal window here for the sake of just having it. Yeah. I mean, it seems to have nerd. What's it called? Nerd. Envim tree open, right? Much better. There you go. Now we have we actually have a working editor. I'm using JetBrains tools and NeoVim Atom for language without JetBrains ID. Oh, cool. Now, I've installed a few language servers here. So I want to see if it's all working. So let's go into my project, shall we? By the way, if you guys are interested in the project, I left a link in the description there. You can see the whole code. So I'm going to be working from the main repository here. Let's actually create a new branch first. Check out the... Let's call it CPP 20 modules, right? Let's push down. Git push. I'm hoping that you guys can see the thing well. Let me know if you can't see the text. We need origin here. Okay, now we have a branch that we can work from. Yeah, let's open Vim. Can I just do this automatically anyway? So if I go into my Vim config, just at the very end here. Oh. If I do nenvim tree open down here. Yeah, good. So we got that opening automatically for us now. Good, yeah. We're sorted out. What happened to your GitHub activity chart? Yeah, dude, there's something very weird, strange happening this year, which is called work, and unfortunately, I wish I could contribute more, but I've been, you know, in the last few months, it's been very busy for me. But yeah, you know, you can see when I was unemployed, because I had a lot of contributions per day, and that was a good time. So basically, when I have nothing to do during the day, coding is always easy, but it is what it is, right? Good. So now let's open. Let's just take a look at the main file here, or not the main file, so the base64pp. So this is the main file where I kind of have all of the definitions. This can kind of piss off now. Okay. Good evening, gents. Good evening, Slovensky. Good to see you again. Snake or something, I don't know. Oh, what happened to... Oh, snake or something. What happened to my GitHub? I'm interested now. Let's see. Did something happen to the snake? Is it not working anymore? It might be broken. It still works, right? I mean, it's missing the some of the contributions here, but yeah, I can show you how this is done though. It's like a GitHub Actions thing. I'll paste it in here so you can do it for your GitHub if you want. There you go. That's what I use. So yeah, I mean, the main point of this library is to export encoding and decoding functions for base64. So you pass in a bit of binary to it, which is like, I think it's a spam of bytes, and it will return you the string, this base64 string, right? And you can kind of see all of this in the header. So you can see here that we've got the namespace, base64pp, and we have like an encoding function, which will take, as I said, like a blob of data. So in this case, it's like a spam of bytes in here, and it returns you a string with the base64 encoding for it, right? And we've got encode string, which encodes just a string, and it's just a specialization of that function. And we also have a decode function, which takes in a base64 string, and it may return you a valid binary if it's a valid base64 string, right? So that was the main idea of it. And I actually created this library for a blog post of mine. So yeah. So what we can do now is we can research into how we can turn this into a module, right? Because quite honestly, I have absolutely no recollection of how to use modules in C++ anymore. So let's begin by doing what every good developer does, looking for C++20 modules in CMake, to firstly add the CMake support for it. And just to make sure, we should have a modern enough version of CMake here. I think it has to be, yeah, more than 26, 3.26, which we're on 3.28, so that's fine. I can send you a good blob about, oh yes, please stop. If you have like a recommendation, we'll read it together and we'll try and follow it together. That'll be interesting. But for now, since it might take some time, I am gonna just try and Google that myself. So C++20 module CMake. There you go. There is a new article by Kitware that they've released basically like a few weeks after I released my video, where I explained that CMake support is still experimental and so on and so forth. And straight away they made that video irrelevant. So by releasing this article and saying that CMake now fully supports it. So this is a good start for us. We can start reading this and see what we actually have to do here. So alas, the experiment is over. CMake 28 has official support for C++20. So you need to have CMake 28, 3.28. The modules enabled without having to set this flag. This has been a long adventure involving the coordination of the SG15 tooling group and developers of major compilers. Okay. Another question is, which compiler do I actually need for this to be supported? Because I have currently got GCC and Clang installed, but I'm not sure if they are the correct versions. So GCC 14. I need Clang 16, right? Let's see if we can get Clang 16 installed. That's the first thing. I will be compiling with Clang. GCC as well, apparently, not just Clango MSVC. So I thought that too. So we need sudo apt-get install Clang. This is Clang 14, so I can't install this one. I need a newer version of Clang, right? I need Clang 16, right? So yeah, let's see what repository we need. So Clang 16, Ubuntu 22.04. Check Discord server. Thank you. I'll check that in a second. Let me just get Clang installed, and then we'll do that. Oh, do they really not have a repository I can just download from? How to install Clang 17 or 16 on Ubuntu? Okay, yeah, let's do that. So apt.llvm.org, llvm, okay. Cool. So yeah, let's try this out. I'm gonna put it on the other screen here so I can follow it. Let's go into our create a directory called temporary for now. Let's do that wget. Okay, so what do we need here? What did not work? This script must be running as root. That's fine. I can do that. No, I'm going to cancel it, and then I need the version 17 here. There you go. Adding repository. I'm going to type enter to continue. There you go. So this is adding all the repositories for LLVM builds. That's good. So we're just getting Clang installed here for those who are wondering. There you go, installing Clang 17. And then what we can do now is once we have Clang 17, we can modify our CMake settings. Sorry, the CMake presets. So we have a Clang 17 build configuration there. So Clang 17. There you go, good. So we now have Clang 17, which means we can go into our project again. I'm going to be going back and forth here quite a lot. Let's open Vim, and in here, let's open the CMake presets. Okay, and then what we need to do here is add a Conan. So Unix, build. Let's add another one here called. Oh, maybe we'll create a Ninja one now, right? Shall we? Might as well use Ninja. I think it's more likely to support modules anyway. Unix Ninja. Oh, just Ninja, I guess. Yeah, Ninja is the best. Usually tends to be a lot faster as well as a build system. Let me just make sure that the string is right. So CMake Ninja generator. Actually, CMake generator. Let's see the available ones here. Ninja generator. So it's just Ninja. Okay, good. Just making sure that we got the right string. So we have. Ooh, gone too far now. Where is Ninja? Why did I add it? Am I crazy? Unix, Ninja, there you go. So generator is Ninja. We got the CMake flags here. And all we got to do now is kind of create a new Unix release and debug. So let's create a new Unix for Ninja as well. We're going to inherit from that Ninja generator. Unix release Ninja. Unix make release. Unix Ninja release. Okay. Change the build output as well. So it's going to be, all my build files will be in Ninja. Sorry, a build Unix release Ninja. And we're going to inherit from Unix Ninja here. Okay, and then a CMake pre-install. We're going to do the same thing. Just going to put it in Ninja. Oh. And we're going to test this out in a second. Let's do, you know, the same thing for the debug one. So we've got debug here. Have I missed something out? Okay, why is this white? Okay, I'm a bit confused now. Well, let's see. We must have made a typo somewhere. So we're gonna do a debug here, and another Unix debug Ninja, and then we're gonna turn that into a debug as well. Okay. And now all that's left for us to do is to come down here and add a build preset for it. So we've got the configure presets, just need to add the build preset here. Unix debug, Ninja debug, Unix make debug build, Unix Ninja, right? Oh, is it Unix Ninja debug? See, I've got a memory spam of a goldfish, 2 seconds, and I forget what I've just written. So it's Unix deb Ninja. Okay. Yeah, so Ninja here. And then to keep it consistent, let's put a name there as well. Configuration debug, good. And of course, we're going to do the same thing for the release build, which is down here, actually. I know I'm getting some messages on the Discord. I'll check it in just a second, guys. So Unix. Yeah, so rel, okay. Just making sure it's the same thing. So Unix rel Ninja. Okay, configurations Ninja. Essentially, we should have the presets. Oh, I completely forgot to add a Clang one, didn't I? So in the Ninja build, let's build it with Clang. So wherever we have Unix release, whenever we have, come on. Yeah, this one. So we want to put the compiler here. I'm not sure if that's an option though. Yeah, I'm gonna search for this. I'm not sure if this is an option. In the meantime, let me read some Discord messages. Okay, I got it. I'll keep that up here so we can take a look at this article in a second. So we know we hear your messages. Yeah, dude, things are going crazy on the Discord. Yeah, anyway, so what was I looking for? I was looking for the way to set the compiler. So configure, so CMake presets. The actual documentation for the CMake presets is actually pretty good, to be honest. It tells you all the options here. So there will be a compiler, CXX compiler. Yeah, no, I think I just have to set the CXX compiler then, which is fine, I guess. So in the cache variables, we can set CMake CXX compiler to Clang 17. Right? And I think that should be it. Right? I'm not setting the compiler anywhere else, right? Good. Now, if this worked, oh, I don't know why I closed them. If this worked, we should be able to go into our build. Let's open a new terminal just for the sake of building shit. We should be able to do a CMake like list presets, I believe it is. Oh, there you go. There is an error somewhere. Line 43. So okay, line 43 or 18. I don't know which one it is. CMake presets, line 43. Okay. So could not read presets from this invalid preset Unix deb ninja. Okay, yeah, just a naming thing. So we Unix deb ninja. It's an invalid preset apparently. Name Unix ninja debug. Okay, so why is this invalid? Good question. Unix Ninja. Inherits Unix Ninja. We do have Unix Ninja, right? Unix well. No, we've got Unix share. We've got Ninja here. Okay. Maybe that's why. Not very... Yeah, that was the issue. I mean, that error sucks, by the way, because that was not the issue. So CMake needs to sort this out. The actual issue was the preset is invalid because we inherited from a non-existent preset. But checking... Yeah, thank you, Anton. Thank you. So yeah, we should be able to now at least configure, right? With CMake preset Unix. Let's do debug ninja. Right, CMake was unable to find a build program corresponding to Ninja. Yeah, ooh, yeah, of course it's unable to find it. So let's do a pipx install Ninja build. Does pipx have this? No. Does sudo have this? Sudo apt, yeah. Install Ninja build. There you go. There you go. So, okay, what didn't work now? CMake error at pipx venv packages CMake. Could not find gtest. Yeah, okay. And could not find gtest. That's actually because I don't have gtest installed. Because if you look into my project, I have a Conan file here. So let's try and get Conan installed, and then we install that, right? So sudo pipx install Conan. This should hopefully install Conan 2. Conan time, yeah. Oh yeah, Robin, you're asking me what a good project layout would be for C++, and this is a really good one, by the way. Check out the code. I remember spending a lot of time on the CI/CD for this and all the infrastructure stuff, and then all the package management and the project layout as well. So you can see how it's done in the real world, I guess. This is a good example. I love NeoVim and build system coding streams. Thank you, man. Let's hope that other people like it too, so we have, you know, way more people watching at the same time and way more fun, I guess. Yes, did we install Conan? Did we install Conan? Yeah, we did. So we've got 2017 now. Yeah, let's install Conan now. So Conan install this, and the output folder will be in Conan. Oh, I need to do the Conan profile. Okay, so we've detected a profile. Not quite right though, so we've got to change it because I want to use Clang 17 here, and it's picking up the GCC compiler. And the wrong version of C++ standard as well. I need to check what we can add here to make it work with C++20. So that's the first thing we've got to solve here in the Conan auto detection, because it kind of is wrong in that case. So let's look at Conan 2 documentation. Profiles. So cppstd, that's what we want to kind of replace with C++20 here, because we need to have C++20. libc++ libcxx. What are the possible values? Are we going to get there? Okay, I guess this will do. Yeah, we need libstd C++11 because of Google test. I just know that Google test has some issues with the strings when it's not this implementation of the C++ standard. So this here is the implementation of the C++ standard. You can have libc++, for example. You can have libstd C++11. So yeah, let's go for libstd C++11. And we're also going to go for 17 on the compiler version. Okay, cool. So let's follow this. So clang libstd C++11. Let's not forget that. And then we can go into our :2 directory. I think there's profiles and default there. The default one will be, so we won't release on the default. Let's put clang here. This is what I need to find out, and this is correct as well. Compiler version is 17 in our case. This is what I need to replace now. Instead of GNU 17 as the default C++ standard version, we want 20, right? Otherwise, modules aren't going to work. So cppstd, is that what it was? Yeah. Default to C++ for Apple Clang. If you want to use a different C++ standard, you can edit the default profile. Let's see what versions are available for Clang though. 17 is the default. Why is it not picking the right compiler? So :toolchain set here. Clang 17 is here. The CXX compiler. Okay. Yeah. Just for the sake of getting this working. There you go. Now we've got both compilers set correctly on the CMake. Do you think about RIIR? What do you mean, like resource? Wait, what's IRR? What's RIIR? I'm actually not familiar with that. Google it. Yeah, I will Google it. Just give me a second. Gtest. CSD def is not found. What the hell is that? I mean, this is a C header. Why is it not finding it though? That's the problem. Yeah, that's very interesting. Let's see if someone's already had this issue. It's not finding one of the headers. Okay, maybe we just gotta do this. We're just missing the headers on the system, right? Yeah, good. It's building further now. RIIR. While this is building, let's find out what SOP is recommending to us here. I hope it's not anything rude, man. Rewrite it in Rust. No, I don't believe in that shit. I'm not even gonna go any further, man. There's too much software, and this is why we can't rewrite everything in Rust. When you look at some companies, some big companies, I'm taking Microsoft as an example here, but that is probably the biggest company you can probably think of. They've got like the whole Windows ecosystem implemented in C++, and this has been work that's been done over literally like over 30 years, right? So if you're rewriting everything in Rust, or even the very sort of like core part of Windows in Rust, it's just going to take too much time and it's not going to add any value to a company at all whatsoever. So, you know, for the sake of being productive, it's just not a good idea to rewrite everything in Rust. However, what I do think is good is to write new pieces of software that you don't necessarily need to have a lot of like dependencies on C++ code in Rust. So, because that can kind of prevent bugs, right? But like rewriting past code in Rust is just not gonna happen. And in fact, none of the companies are doing that, by the way. I know there's like a lot of news online, but those are just like cherry-picked news that you can see. Like, oh, Microsoft is rewriting Windows in Rust. That's not a thing, by the way. They may be writing new software in Rust, but I doubt they're going to rewrite core parts of the system in Rust. It's just unfeasible. It will not, man. Trust me. Yeah, this code rewrote the backend in Rust and Exchange. Yeah, that's true. We've all seen the blog posts, right? But do you know why they've done that? It says it in the post is because they were having issues with scalability, right? So in fact, the main core part of the software wasn't scaling well, so they actually had to rewrite it. They had to make it better, right? So in that case, when you actually have to do something, it may be worth doing it. But if something is like working just fine, it's basically a waste of time to rewrite most things in Rust, or rewrite things. There's a very good saying that goes like, you know, if it ain't broken, don't fix it. So, but saying that though, I am a fan of Rust. I love writing Rust. I feel like I'm way more productive in Rust than C++ because I don't waste as much time on very stupid things. But yeah, that's my opinion on it. And CeliaDB, yeah, CeliaDB is actually, you know, if you look at the source code for it, it's C++, isn't it? So I think it is anyway. I may be wrong here, but I remember looking into it and I was actually impressed. Anyway, so we should have all the shit to build now. So if we do, yeah, it's C++. You know, sometimes having unsafe code is actually good. So we want to CMake preset or list presets. I can't remember which one it was. List presets, and we want to use CMake preset Unix rel ninja, or Unix debug ninja, right? What are we missing here? Oh yeah, we're missing one of the things that we missed in the CMake presets is the toolchain file, right? So for example, Conan debug here should come down to, what is it? It should be inherited by the Ninja debug as well. Ninja debug, let's look for that. Yeah, there you go. It's funny that Rust Lang page says targeting low resource devices need low level control without giving up higher level conveniences. Rust as you. They say that, dude, but like, if you look at the number of devices that Rust can compile to, like the list is very short compared to C and C++ still. So they have a lot of work to do, and they will get there eventually. But if I'm trying to compile code for like an FPIC, a PIC microcontroller, for example, you're gonna have a hard time doing it in Rust, and a much easier time doing it in C, for example. All you need to call C functions unsafe. Yeah, I mean, yeah, if you're doing unsafe in Rust, you might as well just do the unsafe straight away in C, right? That's my opinion. So let's do that configuration again. Oh, so let's remove the build directory first. So he's not getting this toolchain file here. Toolchain file. Conan debug toolchain. So what's inside Conan? Conan file. Oh, love that. So we're not getting the generators, right? We missed the generators on the Conan file. Oh no, it's here. So what's going on? Well, I am confused now. So. Ah, that's why. Yeah, we did Conan release. Let's do a debug now. So Conan debug. So we need to add a new setting here for debug as well. We need to build. What is it? I think it's like S build type equals debug, isn't it? Invalid setting, debug is not valid. Okay, yeah. My bad, Conan, my bad. It's not my fault you can't just compare two strings in lowercase. Even C++ is used only sometimes in embedded. Yeah, no, C++ is not used at all in embedded. Like I used to work as an embedded software developer, and the true embedded stuff when you're when you're programming for microcontrollers, it's all in C. It's just easier. The compilers are easier to write, like linker scripts and that kind of stuff are much easier to write in C. But we did use C++ though in our company as well, because we had a build system for C++ down to a Qualcomm processor, which is considered embedded, but yeah. But yeah, in embedded it's mostly C programming. Yeah, now let's see again. CMake preset. Yay! We built. So I guess we can also build this. So if we do a CMake -- build with the same preset name, we should have everything working. Ooh, except we don't. Why? Oh, this is what I mean. So if it's a string issue, I know exactly what it is. In function, new allocator. I mean, this is the average like error in C++ linking. Right? Undefined message operator. Undefined reference to operator delete. Okay. Yeah, as I said, there is an issue with gtest and the libstd options. I think it has to be a certain. I think it's libstd, std C++ 11, which I thought we had, but you know, this is the underlying issue here. So we need to basically, maybe we need to recompile from source here using the Conan. So build everything. I mean, I thought that's what we did anyway. So yeah, we do have libstd C++ 11 right here. What is the purpose of the Google test library? I have tests, so I have unit tests here. So when you build in debug, it builds the tests as well. In release, it doesn't do that. But I just want to make sure that everything's working fine. Seem very busted, so have fun reading CMake info. Good night. Yeah, good night, man. Good night, Sop. It's good seeing you. CMake. No, we're still having that issue. Let's see if there's an easier fix to this. I thought it was just a colon G test. Basic string. There you go. Everyone has this issue whenever they include G-test with Conan. It's just a thing. This is not that issue though. Yeah, there you go. Because error contains basic string, this hints to a missing or wrong C++ standard library. So libstd C++, your profile contains that. With Clang 10 on Linux, the default is usually libstd C++11. With Clang, this can be changed by passing libstd C++. Okay. So that's what we need. Let's try that one. Oh, I got the wrong one. So Conan 2, and then we've got profiles and we've got default here. So we have this issue. Oh, okay. Okay, let's try again now. So Conan install build everything. This is another problem here, Robin, with Conan. So sometimes you have to get the settings just right for a particular library. So Google Test is a good one, for example, because it's a very popular library that everyone uses for unit tests. But if you don't select the right standard library implementation, your build will not succeed, basically. There's going to be a mismatch in there somewhere. Can I just build this? Wait, let me nuke the build directory just in case. Ooh. Okay. Link in. Oh, for God's sake. We still have issues here. Trial and error, basically. I like it, yeah. I mean, it's not ideal, really. I mean, usually you'd expect these things to just work, but yeah, undefined reference to O string. On GCC, I know that I can build this with libstd C++, but we're gonna keep looking. Lenny, hello man, welcome to the stream. So, what is the issue here? Changing the profile settings to libstd to solve this issue for me. But I have that. So what is the issue? libstd C++ 11, right here. I keep missing the... I start programming 2 months ago. Nice, man. Keep going. I mean, in a year's time, if you keep going, you'll be as good as me, or better, in fact, because I'm not very good. So you'll definitely be a good programmer. Just stick to it. Do you not overwrite with the args in the beginning of the Conan command? That's what I'm on. Yeah, that's a good point. Did we do that? Let's see. So if I run the Conan install, and I just stop it right here, interrupt it. No, it's still the right one. As I can... Ah, build type release. That's why. Wait, yeah, why is the build type release? Oh no, they're profile host, profile build. Yeah, that's interesting. Architecture x64, x86 64. Let's do some more Googling. Let's put Clang on it, maybe yeah, do we have to set that? I mean, CXX is kind of... What is the problem, Maddie? The problem is Google test is not building. Yeah, and it's an issue with the C++ standard library implementation. I've hit this issue many times, and the fix was just to simply set the libcxx here to libstdc++11, but that doesn't fix the issue, so we still have an undefined reference to strings. Is that Linux? Yeah, this is Ubuntu. This is Ubuntu. Let me try and focus a little bit here, and maybe we can solve this. So this guy is like very close to me. He's got Clang in terms of configuration. He's got Clang, and it's running on Ubuntu as well. We have the profile here. The build type is debug. With Clang, this can be changed by passing this to CXX flags. Okay, so maybe we also have to set this to the CXX flags in it, I guess, right? Let's try that. That's the missing. Let's hope that that's the missing link here. So open CMake presets again. Go down to my Clang. So Unix Clang. Let's add that in now. Oh, let's just write it. And then in here, we can try and compile it again. Let's try and build it again. Build. Nope. May add into your Conan profile. Do you mean to send any more messages? Maybe your message is getting blocked there. I can't see it. I only see like adding to your Conan profile. And yeah, Conan profile is already here. Like you can see it's kind of there already when I run the Conan build command. So if I run that, you can see that the profile already has the correct settings here, which is kind of a bummer, really. I mean, I can still build in release. That's not an issue. But I would like to build and run the test as well, though. That's the problem. Before I even get to... God damn it. Something so simple, yeah, so stupid. There is a build type option in Conan profile. There is a build type option, and it's set to release as default, but I override it with debug. Is the enable testing function in CMake that includes the gtest? In my case, I include it with find package. So, but I also run that function because you need to run that function if you want to enable test discovery with CMake. So what is this problem here? I have looked for more information regarding libstdc++11. regarding Conan was libstd++11 was introduced in the Clang settings, and the compiler flags used for that is this set. Okay. Yeah, this is the issue. That's the change between libstd++ and libstd++11. glibc has a C++11 ABI for the strings because they kind of broke it once they moved from C++ pre-11 to C++11. The standard kind of broke the string, and that's the underlying issue here. So essentially this is fixed by adding C++11 implementation here. But yeah, they have like different names basically. It's a name mangling. Inside the binary, this is what you get, by the way, when you compile with different C++ standards. You can see that the name mangling here is, or the names of the string here is different. So that's why it doesn't find it, and you get a linking error. Taken by compiler. The compiler here doesn't matter. It's the same for libs. Okay. Maybe we'll try libc++. I mean, this person's claimed that it doesn't break the ABI, so maybe that's what we can try. And we want this one here. Yeah, this doesn't. It's not able to compile a simple program. So it doesn't work with libc++ at all. Interesting. So it has to be one of those, I guess. Has to be libstd++11, right? I wonder if the compiler standard has anything to do with it. Let's check. Let's check it out. I assume not, but you know, it's worth a try anyway. It's worth a try. No, it also doesn't work, yeah. Damn it. God damn it. God damn it. God damn it. God damn it. What's on my CI file? Let's have a look at what's on my CI file. Also, why I'm not... I don't know why I'm not seeing the toolchain files here. Interesting, this. But anyway, let's see what's on my CI files, because I do have scripts that build this on the CI. So the gtest does not run at all. If I build for release, it shouldn't build at all. It shouldn't run at all. So if I build for release now, it should just pass. Good test. Oh, there you go. So if I build for release, it doesn't build gtest at all. Do not the toolchain file get replaced in the build folder, or have you specified? I've specified another location, Conan debug. So it's inside Conan, and deb and release here, as you can tell. But I kind of want to fix this. I'm going to spend like another 5 minutes. If it doesn't work, we will just move to the release builds only, and we'll try. I'll try fixing that some other time. I don't want to waste too much time on stream. It's a bit boring for you guys. So Conan, gtest, clang, basic, string, error. Quickly scouting things. I don't mind troubleshooting at all. Really, yeah, it is really informative, but I know some people kind of tune off the stream when I'm like stuck on something for too long, so. This is just really annoying. Like, it's something we shouldn't get stuck on at all. Yeah. Interesting. So build x86-64 here. Is it just building with kind of GCC in this case? Yeah, I'm not building with Clang at all on the CI. That's why I didn't notice this issue before. Go back to Googling. What am I doing? This is not the correct error. Colon gtest, basic string error. I mean, yeah, the main article is the right fix, because I've done this before, but I have no idea why it doesn't work. We can add this definition, I guess, right? If we wanna just bypass this ABI breakage. CPP flags, okay. Yeah, let's do this. So on Clang maybe there's another issue. So we need to pass this here. I don't really like setting the compile flags straight away. I mean, any like compiler dependent flags on the presets, but this is maybe what we have to do. I don't know why I closed it before. So CMake presets, and let's go to Ninja again. Let's try with 0 and then we'll try with 1 and see which one works. Dude, why do I keep closing it? Okay. Is he even passing that flag down? New CXX 17, normal iterator. Undefined reference to basic stream. If we do 1 now, what happens? And just to make sure, which Conan build do we have? Conan install. Clang 17. Let's see. CXX flags. Maybe that was the issue. Let's see if we can pass this down. What do we have? A CXX flags in here? Does it say the environment? No, it doesn't. That does nothing at all. Nothing at all. Now let's try with Conan's, the other C++ standard implementation here. So CPP compiler dot libcxx, I think it is. Lib stdcxx C++, just that. Gosh. This is so annoying, guys. What the hell? Let's try with 0 now. On that. Oh, I need to probably remove the build directory. Yeah, some of this combination is going to work at some point. What if we remove this one here? And then just remove that one as well. I'll let Conan figure it out. So what was the last Conan that we had? We had lib std C++. And then we also have cxx 11 ABI 0. And that is what's recommended, right? I'm not missing it. So with Clang, this can be changed by passing lib std C++ to the cxx flags and ld flags, and this to the cpp flags. Okay. So this is what we need for the cpp flags, which means cxx flags is here. And then what happens if we reconfigure and then do a build? Nope. Yeah. This is mildly annoying, Select the old libstd C++, compile options. Add link options. Out of interest, if we just add this to our CMake, what happens? So in the main CMake files, CMake lists, we just add that there. Nope. Yeah, we're not going to do this today, so I will take a look at this some other time. Let's just build in release and hope for the best. But anyway, so release is building fine. We're just going to, I guess, actually start modularizing things. And there was a nice article that SOP sent me that I need to find out, where we can kind of just follow. So understanding C++ modules, part 1, hello modules and modules units. So my previous posts on modules have received a lot of attention. I'm happy that I've been able to kickstart a lot of conversation, but I've also seen a large part of the community still unclear on what modules actually are. Yeah, if you don't know what modules are, I've got a video linked on this video, and you can find out more about it. Right, let's see the basic syntax for it. So there is a hello world program using C++ modules. So we have to declare this export modules at the very top. And we can import the functions like this. So import IOStream and import speech. So in essence, what we want to do here is like all the code for the base64 namespace, we're going to turn that into a module. Kono has a recipe for gtest, by the way. Yeah, they do have a recipe. That's what I'm using, by the way. I've got a recipe for gtest as well. I'm pretty sure I took it from them. The only difference is that not building with Clang, I think. I am. So Clang 17 to be precise, which is like the newest version of Clang. So let's try and kind of like mimic this into our in our library. I kind of am interested to know what other supporting files we need as well. The effect of importing a module is to make export entities declared within that module to become visible. Okay, so for every function that we want to export, we just put an export keyword in front of it, kind of similar to Rust's public, right? It's the same thing here. So the effect of import, okay. Module names. A module name is defined by the aptly named module name. The following is the grammar of a module name. So that's what it accepts. Module name qualifier, index. Identifier, sorry. Okay. Cool. Yeah, let's begin making some changes here. So we've got the C++ standard set to 20 here. I'm gonna remove all this shit because it didn't work, and we're gonna figure out why later on. And we're gonna open the base64 include here. So essentially, like with modules, this whole thing is gonna disappear, right? So this whole file is gonna disappear, and this is all gonna be in the CPP file, which is now here, right? So I'm gonna put all of that in here for now, and we're just gonna copy and paste the code into here. We no longer need namespaces with modules because it's gonna be namespaced with the module name. What we do need is to have the module identifier at the top, right? As you can see here. So we need export module speech. So let's do that. So at the very top, we're gonna put export module base64 pp, right? And then we have to just put the declarations of the functions where they should be. So encode, for example, is going to be, let's put the namespace up there above everything. Okay. We no longer need the header defines here. The header include our guards, because modules sort that out automatically for us. So there's less code. And we've got the anonymous namespace here contains all the functions that are only used within this file, by the way. I'm not sure, I don't think we need anonymous namespaces anymore with modules, because it just works out which functions aren't exported. So in a sense, we can remove that already. So yeah, and let's just indent it properly here. Okay. Right, the first function that we've got to find is where the encoding is, right? So let's move this documentation to where it should really be, which is here. Found it very quickly. So we've got encode, and we don't need the export macro anymore because the modules are sorting that out for us. So export headers are not a thing anymore in C++ modules. And let's just do the same for all the other functions now. So we've got this one. Ooh. Encode string. Is that encode string? Yeah. Just moving the documentation to the proper places, basically, because... And of course, we need to export, right? I think it is. Is that the keyword? I'm not mistaken here. Yeah, there you go. That keyword is going to sort out the exported functions for us. And again, we need to do the same thing here on the encode string, because we're actually exposing this to the user. Okay. Right, what's the next function? It was just this one here, decode. And we no longer need, as I said, the include guard, so let's move that away. You can see that the decoding function is reasonably larger than the encoding ones. And there's a reason for that. You're doing a lot of like input checking on this. I'm not going to explain how this code works. If you're interested, feel free to check the repository. So, okay, we need another export there. So in a way, we moved our file-based, our header-based thing into our C++ modules here. I am going to get rid of some of the headers that we don't need anymore, like the actual header for this file. CSTD is already included up there. Optional is already included up there. Spam is already included up there as well. String is already included up there. String view is already included up there. Okay, good. Now the main goal is to turn these into like import, right? Imports here. So I'm not sure if Clang does support importing the standard headers as a module. So let's check that out. So Clang 17, Clang import std. So I know Microsoft has an import std which imports the entire standard library for you. I'm not sure if Clang supports that. So C++ compiler support import is that a thing? So modules. I actually missed what the guy was recommending, to be honest. So Clang import std. Standard library modules, okay. So just Google for modules here, standard library modules. So we have partial implementation of Clang 17. Okay. So let's see, we'll further Google Clang 17 standard library modules and see which ones are available to us, because we're going to replace some of the includes with the module imports. Is this going to help me? Yeah, so include yeah, they're still using includes here, so import. What are the headers they're importing here? Or the modules that they're importing? Let's see. Yeah, there are no standard library imports here. There you go. Quick start for the following. So let's just add all the headers as imports in, and we'll see if we need to comment any of them out. Kind of leave them actually. Let's replace everything actually. Include with import. There you go. So we got that. I do wonder if it's going to compile though. That's the issue. Right, so we need to take a look at the CMake lists for this project as well, because we no longer have all this bullshit which kind of does the automatic export headers for us in C++. We no longer need that. There. So, and that code I just removed basically creates the export headers for your DLL or your shared object in Linux. So we no longer need that, because the modules kind of came to fix this, I hope, right? File globbing public headers, we don't need this as well because it was to do with that code. We don't need to generate export headers. We don't need this. Wait, did I? Oh no, this is the install stuff. Never mind, I removed the wrong code. This is the install stuff. We need this. What we don't need is... This is the package config stuff. We leave that there. I don't actually know how this works. Someone just randomly added this to... not randomly, but some guy added support for package config. So I'm going to keep that there. Install directories we keep. This is what we don't keep, basically. Yeah. So, and this as well. And this. Now, obviously the CMake is going to change. There's going to be some extra module stuff here. And this is what we're going to find out how to do, I guess, right? That's what we're here doing today. So add library. I add the basics for pp, which is based on the C++ file. the sources and include this. Where am I using the sources here? Okay, these are kind of in use now, but we get rid of them later. You know, back to the post. So let's keep reading this. So this is an extremely straightforward example. We have a single source file that exposes a module speech. Our main CPP imports speech and uses the single function defined therein, getPhrase. The effect of importing a module is to make the exposed entities declared within that module to become visible by the importing translation unit. No more, no less. A few questions which will be answered below. Why export modules instead of just module? How are modules named? What are the rules? Okay, we've kind of read through this already. So a new C++ source entity. For all C++ history, there has been one standard concept to encapsulate the idea of C++ source code, the translation unit. This is something that, you know, you should know if you're doing C++, what a translation unit is. So if you don't, Google it now, because it's like how headers and C++ files kind of work and how they come together in compilation. So C++ modules introduces a new type of translation unit called a module unit. The definition is fairly simple. A module unit is a translation unit that contains a module declaration. What is a module declaration? Well, we've already seen one in our example. So this is the example we had previously with the naming rules there. I'm not going to go through this. Like, this is basically talking about translation unit and how modules can kind of help out with that. So I'm just interested in seeing how this guy's compiling this with CMake now. Is it even doing this with CMake? Submodules are not a thing technically. Another way we could have subdivided the prior example. Okay, well, I should probably read the important message as well. The primary interface unit for a module must export all of the interface partitions for the modules either directly or via the import part name. Otherwise, the program is ill-formed. Okay. Yeah, so it's just saying that it must export something, right? Otherwise, you can't have a module that doesn't export something. Partitions for the module, okay. So module implementation units. So far, we've poked at module interface units, but there's another type of module unit. This one I don't remember reading about, so this is kind of new to me. The module implementation unit. A module implementation unit is a module unit which does not have the export keyword before the module. The implementation unit belongs to a named module. Entities declared within an implementation unit are visible only to the module of which they belong. Okay, so this is kind of what our implementation functions could belong to, I guess. So the ones that are not exported, we could put in a different file. Is this what it's saying? I'm not entirely sure here. This has the probable advantage of keeping details hidden and possible benefits of helping accelerate incremental builds. Okay, so if you're including all the modules inside this module here, you don't want to export these dependencies as well, right? This is what I'm kind of getting here. Is that correct? Would you guys understand this? I'm having a hard time here. This looks similar to before. The import partitions in the primary interface unit no longer has the export keyword. Yeah, I see. Module speech. Looks like a virtual function to me. Well, it's not. Yeah, it kind of does, doesn't it, actually? Oh yeah, you are right. This is essentially just a virtual function. Yeah, it's exactly that. So, I mean, I guess hence the name interface modules, right? It's just an interface, and an interface in other languages are exactly that. Just something that you know, an interface is something that says, you know, that if this structure follows this interface, then implements this function. So, I guess yeah. Kind of looks like that. That's a good good reading into it. and then you can override the implementation details in a different module. That's cool. I didn't know modules did that, to be honest, in C++. This is kind of new to me as well. Okay. I mean, this is all good. I'm kind of just trying to see if we can compile this now. So there is a second tutorial. Are they going to do CMake on this? Oh, I've upset the compiler. This is a really cool, this is an amazing 404 page. This is amazing. Like, what the hell? I like that. Let's look at the next article here. Export, import, visible and reachable. Okay, there's no CMake here. I'm just interested in looking at the CMake for all this, to be honest. No CMake here either. I am going to read this thing on my own time. I just think like reading this on stream is kind of like a little bit cumbersome. Is there any CMake here? No, no CMake. Okay. So these are 3 really good articles which SOP gave it to us. I'm going to post it here if you guys are interested. Which I'm definitely going to read the rest of it on my own time. And it seems to explain very well what CMake modules are. This is amazing, actually. Kudos to this guy, Vector of Bool, Yehobayo. So, right, let's go back to the kitware. So, CMake C++20 modules, because this is definitely going to contain the there you go. Please see this article for an update on how to use modules. Okay, yeah. This is the first article I was kind of talking about at the start of the stream. So yeah, previously we had this flag that you had to enable on CMake, experimental CMake CXX modules. And so versions. Let's keep reading from here. C++20 name modules are now supported in CMake 3.28. And newer when using Ninja and Visual Studio generators. So I'm glad we switched to Ninja. Okay, blah, 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 blah. The rest is not important. Why now? Okay, yeah, just talk about this paper, which kind of describes how the interface, the module interface modules files are generated. I've kind of went over this on the previous video as well. It's a very interesting read, by the way. I'm not going to go over this now. So getting a compiler, we've already got a compiler. Getting CMake, I know we've already got the CMake version that's necessary here. GTOR6723, welcome to the stream. How would you recommend a noob to C++ start learning? I know Python already, just getting into it. Yeah, just create a project, dude, honestly. Like, that's what I recommend to everyone trying to learn something new. The best way to learn a language or a technology is to just do it. Like, you can read an entire book on C++, but if you're not practicing, you're just going to forget everything as soon as you read it. And you learn the most when you're actually doing it. So just get a project, figure out a cool project that you want to do. Maybe it's like a small game. Maybe it's something a little bit simpler, like a CLI program. And then just do it. Just literally just do it. You know, Nike had it right. Just do it. Right here, an example here is very simple. Hello world program that uses modules. The program has the foo.cxx, which implements a module called foo, a file main.c++ which imports foo and uses the module to print hello world. And CMake lists file that contains the CMake code to build the simple example. This is good. So let's see what they're doing here. So they are declaring a module called foo, I guess. So if you don't put the module name after it, I guess it picks the name of the file. Is that correct? Oh no, never mind. It's here. I'm being a noob. Okay, so this is pretty much what we kind of have, isn't it? So import foo, and then this is the cool bit. So turning off extensions avoids an issue with the Clang 16 compiler. We already do this in a CMake. Let me just make sure. Pretty sure we did that already in the main CMake lists. Yeah, extensions are off here. Cool. And then we set the version of C++ for the project. CMake 20, we've got that as well. We add a library, yes we do. And then we set the target sources. This is something that has to be changed now. So previously in CMake, we would always add sources to a library by kind of doing this. But now you actively have to do target sources, I think. It just works better with the module stuff, I believe. And it's kind of a new standard of how you include source files to your executables, your libraries, whatever. And we need that, obviously, as you can see, because of this file set cxx modules flag here. So yeah. Okay, so far so good. What else do we need? Create an executable. We don't care about that one. And target link. Okay. So is this going to build? Like, is this literally all the changes that we have to do for this project? Let's find out. So let's get a trusty little terminal here. And then I'm going to just remove the build directory just for the sake of doing it. And we're going to CMake preset Unix release. Should you not remove the add library? Good point. I think I did forget that, didn't I? Let me see what they have. They do have an add library, but just the file that I should remove. That's a good catch. Thank you very much. Should save me some time. Yeah, so you still have to declare the library though, because you need to have the source. Sorry, the target here, so you can call it in here basically. So add library is going to create a target for us, which is a library target, and then you can modify the target with the target sources in here. But yeah, thank you very much. We did need to do that. So let's see what the issue here. Ninja does not support C++ many modules using Ninja version. Of course, the Ubuntu repository is once again behind in the versions, of course. So and we're going to try and install it from pipx or something now, which will have a much better or much newer version, right? Can we just install Ninja from like a Ninja build from their own script? Install Ninja build Ubuntu. But I don't want the apt version because that is too shit and too old. Is there a pip version of it? Okay, so it does have a pip version. So in theory, I can use pipx here to install Ninja. Yay. Yeah, okay, so right, so let's try again. So, and which version is it? Ninja version. Good, yeah, we have a kitware build 1.11, which does support modules now. So let's try that. So we do CMake. We said why pipx? What's the difference from pip? So pip and pip3 kind of install binaries to your system, which can mess up the already installed packages in your distro, right? So it can mess up with your distribution. Basically, it can break it. Pipx kind of containerizes things a little bit better. So like it's not in your main paths, and it's not gonna conflict with anything in your system, basically. So try and use pipx whenever you can, basically, as far as I know. So right, Ninja version with no such file directory. What? Ah, yeah. Because we don't have user build Ninja. We have installed, where is it? Where is Ninja? See, it doesn't install to the system, as you can tell, because if you do where is Ninja, pipx installed it to my local Ninja here. Now, the only problem is that why is CMake just calling user bin Ninja, not just Ninja? This is very interesting. I mean, sounds like something they shouldn't be doing in case someone has a Ninja installed in a different location. Yeah, I mean, I could just do this really. So I could create a link to it in my user build. So, and instead of that, we're gonna have home Mateos local bin ninja. Is it the other way around? It might be the other way around. User bin ninja. Okay. A little bit of distro hacking, and finally, I mean, I said all of that about pipx, that it doesn't mess up with your system binaries, but I just did the opposite of it by setting doing a soft link to it in user bin. So yeah, I just went against what you're supposed to do, basically. I thought about that, yeah. Okay, preset. Build, okay. Failed. CMake CXX compiler. Dep's not defined. So what's the issue? This is a new one to me. No, not seen this issue before. So we've got CMake CXX compiler Clang scan dependencies. This is to do with modules, to scan the dependencies of modules. Not found. Yeah, let's figure out if there is anything else that we gotta do here. First of all, it probably would be nicer if we can finish the tutorial here, right? Do they set anything that we don't? I do wonder. Okay, so yeah, I mean, they don't explain anything about this, so they don't have that. Let's see if we can figure it out. Tried setting this to user bin Clang scan dependencies. Okay, yeah, let's try and manually set this flag. So basically we're supposed to have the dependency scanner binary from Clang, which scans for module dependencies, in here somewhere. So let's see, use a local bin Clang. Let's go into user, a local bin, nothing in here. Where is my Clang installation? Okay, so we have it in user bin. So cd user bin Clang 17, or just here, I guess. And let's see what Clang things we have. Oops, I meant to grep that. Oh, not cd, sorry. We do list. Yeah, we don't actually have a dependency scanner. Ah. That's why it's complaining about it. Interesting. So the Clang 17 version I downloaded doesn't have that. I don't have to compile this, right? I don't have to compile Clang on my machine. Please tell me I don't have to do that. That would be like painful as hell. Clang 17. Okay, they've got a very shiny page on it. Like a... I guess this is supposed to be a slideshow. But, I mean, I got the binary name here. So maybe if we do a sudo apt install now, it will be there. Because I do remember... not the local compile. Yeah, no. I hope we don't have to do that. Let's update it. I remember that we added the LLVM toolchain, so we do have that there. So hopefully in this LLVM toolchain repository, we can install the scan dependencies, right? No! No, we cannot. Let's see if we can find online what binaries are in it, so we can install them. Dependency extraction. Right, so what do we have here? Debian. I'm trying to see like if we can find a way to see all the binaries in this repository. So okay, okay. First of all, we have 17 somewhere, right? Where's all the 17 dependencies? Here. Yeah, I can't see it available, unfortunately. This is a shame. Maybe Clang Tool 17 will do. Let's try that. Maybe it's in that package. Yes, yes, we got it, boys. Let's go. Our efforts worked out. We don't have to compile it. It's here. Right, so the question is this gonna work with the CMake that we had here? So CMake presets. Hello. Shive, sorry, I can't pronounce that name. That name is too Germanic for me. I don't really speak your language, but welcome to the stream. I don't want to botch your name either. I don't want to be disrespectful. So we can do a build. I'm gonna do yet another bit of binary hacking. It's kind of dependencies. By not binary hacking, but just distro hacking, I guess. Use a bin, because we do have the Clang dependency here, right? But what we can have as well, what it's probably looking for is just this without the 17 on it. So I can maybe update the alternatives. Right, or maybe we just do a soft link for now. I've got user bin Clang scan depths 17, user bin Clang scan depths. Right. No, did not work again. This is not good. This is not looking good. Not looking good. I found temporary solutions to my problem. If you go on CMake's cache text file and find the CMake scan dependencies variable, you find something like this. File path, something here instead. This is hacky as hell. You should not hack the CMake cache, the generated file. CMake CXX compiler scan dependencies. Okay, thank you, Anton. Is that gonna help me? Let's try out. So let's define that in the. Maybe we put that. I'm wondering where. The best place would be here, right? In the Ninja preset. So this is why I love having people watching me coding, because you guys sometimes know more than me, so it's definitely good. So we have CMake CXX, okay. CMake CXX compiler, Clang scan depths. And then we put the path to it, right? Which is user bin clang scandeps, I think it is. Scandeps. Okay, good. So let's try that. Thank you, man, and I hope this works now. So let's remove the cache, the build cache. All right, what do we have here? Scan labs. Oh, there's a mistake. There's a mistake. Typo. It should have been 17 there with this. There you go. I like the emojis there. Keep them coming. So remove build and then CMake presets. Okay, we went further, but what's the issue now? Error scanning dependencies for this. Error header file algorithm, aka this, cannot be imported because it is not known to be a header unit. Okay, yeah, this is where it becomes interesting because it's kind of easy to solve now. So basically what we got to do is, some of these have to be imports from the looks of it. So we're gonna get another one as well, so array. So none of these has to be include, sorry. None of these import statements are supported by Clang. Yeah, basically. Include, yeah. It should be include. Like in an ideal world, they would have had implemented all of these kind of headers as a module, but they've obviously not done it, yeah, on Clang, so we still have to use include, unfortunately. Let's try again. Okay, this is definitely an interesting error now. Okay, what do we get here? Dude, this is becoming too complex. Ensure you have a LLVM symbolizer in your path, or set this to point to it. I'm sure that's not the issue, right? So what is it? Segmentation fault. We actually got a fucking segmentation fault in the compiler, or the LLVM library, the LLVM tool. And do we get any like actual errors at the top? Maybe. Right, I'm a bit confused now. So maybe, is it anything to do with this import by the... Oh, maybe that was the issue. I was still importing a base64 header. Nah. Yes, you are on the deep grounds now. Compiler seg faulting. Yeah, I am. I've very rarely have got these kind of errors before. But it was... I'm guessing it's probably because of these, right? Let's try and just include all of them now. So if we just replace all the import with hash includes, let's see if that works. No, it still doesn't. I mean, better, much better now. I mean, we don't actually get a seg fault. But let's see what the first error is though. CVP line 4, include algorithm. So error declaration of iterator traits in module. Okay, so we need to kind of, I guess, put these after somewhere. All the includes, right? Let's take a look. Where is that example again? Import CMake. What do they have here? Ah, the includes have to be in between the module and the export module. Okay. Okay, I mean, we're getting a little bit better now. Good, good. So now is the errors within our code, so that's much better. So we don't have the base64 pp namespace anymore, right? So we can just remove all of them. Yeah, okay, so let's remove all of them now. So base64 pp. And we're going to remove it with nothing. So gc, let's ask for it. So yeah, we want to replace this one, we want to replace that one too, and that one too. Yay, we got it compiled. Cool. So in essence, I mean, it isn't that difficult to get like a very simple module working, right? Obviously, I don't know everything about it yet, and that's why that article is going to be very useful for me. But with modules, you can kind of tell that we shaved a lot of code. Like we essentially don't need this base64 pp header anymore. So if I can just come in here and go my build, sorry, not my build, my source code, and kind of delete that. So I can base64 pp, and I can immediately just remove everything on my include there. What else do I remove? I mean, these base64 files here, the PCN files for the package config, I'm gonna have to change them. In fact, let's look at what's inside them, because I'm pretty sure I probably broke it. So what do we have? Oh no, this is just package config stuff. That's good. So nothing here has been broken so far. But yeah, I mean, we shaved a lot of code by just having the export modules, right? It would be interesting for me to actually run the unit tests, because I essentially know if I look at my unit tests now, they were all calling the library within the namespace, right? So that's probably going to fail if we look at the tests. So let's look at the test here. So I will have to basically import this as a module now. That will be the main difference. So yeah, I would have to like import this. But the problem is, I'm not sure if well, yeah, let's do that anyway. So import. Let's create an executable for this, right? So the first things that we have to do is remove all the base64 pp namespace. Oh no. Oh, do we leave it as that? I don't know actually. Let's see. How do you call a module? How would you call a module? So they've got an example here. So we've got a library there, and it's with a dot, right? So it's import foo f. All right, so they're importing this module called foo here. Export module foo. Wait, is everything just imported as the namespace, as like inside his namespace without like an actual namespace? Is that how it works? That's interesting though. Yeah, it seems to me that when you import a module in C++ here, in this example at least, it just sort of imports all the class for it that's defined inside the module, inside this namespace here. So we don't have like foo colon foo. It's just foo there. I'm not sure if I like this. I mean, I would definitely like to have the base64 pp namespace at least there. Yeah, but from this change, it looks to me as if we can just kind of then remove that base64 pp namespace, and then just have nothing in there, right? There's so much tests here, man. So many tests I've written. I remember spending literally like maybe half a day just writing all these tests for this library. Cool. I mean, we've got the main there. Now, obviously, we need to kind of turn this test executable into a module as well. So let's do that, and then put it on the CI. We're just going to look at the examples here. So what do they have? They just have an import module at the top. Okay, there's no module declaration here, so it's a little bit easier actually for executables. And any changes on the CMake? That is my question. The CMake list for the executable main.cxx. No, you just add an executable. Cool. Yeah, so let's do that. So at the very top, all we need to do is to import. What am I doing? So to import this now. That's what I got from here. Right, we've got the changes here. I do wonder whether Clang format is going to work with this, because I have a Clang format file there. But yeah, let's push these changes here first, right? So let's add everything here. So yeah, we want to change that CMake preset as well. So we want to change the basics for CMake lists for my library. We want to change the basics for PP as well. So yeah, all of them basically. You're importing a header file now. Should you do that? No, yeah, you're right. It's just import base64pp, I believe, right? Thank you. Another typo. So module base64pp, yeah. Thank you very much. And with that in mind, we also have to add a new change here. Gosh. Copying with Terminator is a bit of a pain. I have to press shift. I keep forgetting to do that. There you go. Okay, so now we can commit. So ported, or just transformed, modularized the library into a module. That's what we did here. What is it? Commit a VirtualBox, your name and email address. No, yeah, we don't want to do that. Yeah, we don't want to do that. How do I uncommit something? So git reset. Ooh. Actually, let's go back in time here. Check out, reset, commit. Let's go back here. Oh gosh. I'm losing my will with Terminator. Yeah, I want to go back there. Nope, wrong thing. Let's get back to that state. Yeah, okay. We can push this. Let me change my commit name so I can amend it. My commit name and email. I got a message, but that CMake profile list you added into Ninja now, do you use a copy of that for all your projects, or do you write a specific one? I mostly copy, to be honest. So I've written this like maybe like a year ago, and I just keep copying between projects, and it works because it should be a thing where you write it once and run anywhere, as long as you have like the right settings. So I've got like presets for Windows, and I've got presets for Linux. If you want to copy it from there, if you want to copy for your own projects as well, feel free to do that. It's on my GitHub repository. The link is on the description there. It's a really good one because you can build with GCC, you can build with now Clang, and then Visual Studio as well. 17 and 20, I think. Sorry, 19 and 20. Sorry, 17 and 22. My bad. I'm too focused on something else here. Yeah, I need to change my default Git stuff, and I think it's like git config email or something. I can't remember. Git config email. Yeah, there you go. I think that's my user for my GitHub, is that right? Yeah, Matthias Gomez. Okay, now I need to amend the commit. Git amend commit author. I keep like, this is something I always come across, but I always forget how to do in Git. Okay, Atlassian. So we amend author. No edit. Okay. Okay, and now we can push. So yeah, I mean, I'm hoping that the pipeline for this is going to work. And in fact, let me take you guys through that. I'm hoping the pipeline still works for this. I've got a Azure pipeline for this one. Because at the time I was very, very much into Azure pipelines. I don't know why, but nowadays we have GitLab Actions, sorry, GitHub Actions, which is free, so everyone should use that. So modularize the repository. And yeah, let me see. Now that we've pushed it, one good exercise is like, do I have Clang format? That's my Clang format. 17? No. Sudo apt. Wait, let's go back to that page where we had all the packages and see what what we have here. So we need Clang format 17. Okay, cool. So we need to sudo apt get install Clang format 17 here. Okay, and now we should be able to run a Clang format 17 there, right? Good, yeah. So, okay. I'm not necessarily sure how I did this. There is a particular command you can take a Clang format file. Oh, why did I close it again? So there is a script where I have the lint. And what do I do in here? Yeah, we can lint now. Okay. So if I alias Clang format to Clang format 17. Okay, I should be able to use that script lint, cpp lint xargs, no such file directory. For the sake of just doing it for this repository here, let's turn this into a 17 there. Yeah, there's a lot of a lot of stuff here. Right, so clang format 17 help. So we need to include the file. I think it's -I for the file. Yeah, there you go. In place files and files, and then we need to take in the clang format file as well. Okay. Let's just run it here. This is another example of code formatting as well. Rob, like if you've ever used clang format, it just does what like cargo FMT does. It's just format your code. And there's a script that does this with clang format, but you need to have this tool installed. And it does it for C++, and it's part of the LLVM toolset. So scripts, SPP. Did not know that. Yeah, good. Yeah, so you can see like it automatically kind of formatted some code for me, and it's all based on this file called clang format, I think, .clang format, which again I wrote ages and ages ago, and you can kind of see like you can kind of mix and match what kind of stuff you want to see. So like if you want to make sure that your code always has the brackets of the if statement like in a new line, you can set that in here. And it's the same thing for like for loops, and there's a lot more stuff you can set. And yeah, it's a good tool to use. And I just realized that this is not going to build on the CI, and I'll explain to you guys why in a bit. But yeah, let me just add the rest of the stuff here. So we want 1, 2, and 3. Oh no, we don't want to send the third one. So we want to update 1 and 3. So we just want a base64 CPP and the tests. Okay, well, let's push that. Is this for the pipeline to check the formatting? Yeah, so that is for the pipeline to check the formatting. But it kind of shows you how you can run clang format over like all of your C++ files there, because it gets all the project files that end in C++, and then it passes them to clang format basically. I just modified it slightly here to include this -I flag and remove the other flags that print out an error if there's anything wrong. Just so it automatically fixes it for me. But on a pipeline, you don't want to do that. Obviously, you just want to check that they are correct, so you can fail it and tell the person to push the right formatting. But yeah, this is not going to pass, guys, on my CI. I just figured why, because well, we don't have the C++, so the clang 17 toolchain here, so it's just not going to pass. So yeah, I mean it's gonna fail right here on the linting. You see, it's gonna fail on the linting. It would fail on the build as well, because it's gonna be building with like I think it's clang 16 or something. And what are you doing? I arrived now. Hey Akira, welcome to the stream. It's nearly the end now, man. So you have to go back and watch it. We were doing some C++ modules, so we're modularizing the library that I have essentially. Is that equivalent with the C++ extensions on VS Code that formats? Yeah, it's equivalent to that. It's in fact it will use clang format. I'm pretty sure. We take a look at that actually now. So VS Code, C++ extensions, format. I'm pretty sure, there you go. It uses clang format internally. So it's the same tool, except I'm using it raw here without any any wrappers on it. Yeah, I mean it's not gonna work. You see that it's got some issues already, because this has to be running with clang format 17, and I'm not doing that. I'm using clang, I think it's clang 16. on this this Docker file. We can check it now actually. So I have a Docker somewhere, right? So vim docker. Where is it? Let's just open it with vim. I'm pretty sure it's like Clang 16 or something. Yeah, Clang 13 in fact. So yeah. I see. So right, what I am gonna do right now, or maybe not right now because it's quite late for me, so I'm gonna call it a night. But what I need to do here is modify my Docker container to actually install Clang 13, and so sorry, Clang 17 for all the tools here. So yeah, and then only then my pipeline will actually pass. So that PR is going to stay open until I can do that. So yeah, but guys, it's been a fun stream, and I'm actually going to call it a night here because I'm like fucking really tired, man. I've worked so much in the past 2 days, and now I'm also coding until 1 AM. So like it didn't really help. I didn't really help myself. But I really had a good time coding with you guys. Thank you, Anton. Thank you, Robin, for joining. You guys did help me out a lot. And Akira, I'm sorry, I'm calling it at night as soon as you joined. But like next time, if you stay tuned, we'll have some more fun streams. And yeah, Peter, you're still here, man. I thought you're gone already. Thank you, man. Thank you for joining again, Peter. It's been good seeing you, man. I hope you're all doing good. Thanks for the stream again, and congrats on this. Thank you for the 1K subscribers. The goal for this year is to get 5 now, so let's see if we can reach that. But yeah, guys, I will leave it here, and as I power it off, good night.